Michael Mann. Welcome to the Climate Pod.
Thank you. It's great to be with you.
Well, it's great to have you on. I know this has been quite a year, quite a sabbatical year for you. I wanted to talk just to start out. You were part of this group of scientists at Penn State University's Earth System Science Center and that projected the 2020 hurricane season to be the busiest in the decade in the Atlantic. What are some of the data points that factor into that projection?
Yeah, so we did issue a prediction, a forecast of a fairly active season, perhaps the most active season since the infamous 2005 hurricane season, which saw 28 named storms and, of course, devastating storms like Katrina that made landfall in the U.S. So the basic factors that go in to our model, and it's a statistical model. So basically, we look at past data. We look at the relationship between the activity of past hurricane seasons in terms of the total number of storms that were formed during that season, and certain basic climate indicators, factors that we know influence tropical cyclone activity.
Right.
And it turns out the two key factors are, not surprisingly, how warm it is in the main development region for these storms in the tropical Atlantic. All other things being equal, the warmer those ocean temperatures, the more energy there is to produce these storms, the more storms you're likely to get. And the El Nino phenomenon, what's going on with El Nino? Because it turns out, even though El Nino is something that takes place way off in the equatorial Pacific, in the eastern equatorial Pacific, it impacts weather patterns around the world. And it turns out that El Nino has an impact on how much vertical wind shear we tend to see in the Caribbean, in the tropical Atlantic during the storm season. And during an El Nino year, there tends to be more vertical wind shear, and that's adverse to these storms because these storms like to form a regular sort of vertical structure. And if the wind is pushing them in different directions at different heights, it's hard for them to form that nice structure. So what we have right now is an incipient La Nina. It's the flip side of El Nino.
Okay.
And that means less vertical wind shear in the atmosphere than usual. And so that's more favorable for storm formation. So if you can forgive the pun, we have sort of a perfect storm of consequences shaping up here this season of very warm ocean temperatures in the tropical Atlantic and relatively conducive behavior in the atmosphere, less vertical wind shear because of this incipient La Nina. It's not here yet, but all the forecasts are for us to sort of steadily move into La Nina territory over the next several months.
So when you build a model like that, is there any sort of numerical output? Like how many storms might the North Atlantic face in the upcoming hurricane season?
Yeah, so we use a linear regression. So if the old-fashioned least squares that you might have encountered at some point, in college.
You're making the economist major on the other side of this interview very happy.
Okay,
you can see how he's smiling as you respond.
So you guys know, so it's a linear regression model, but it uses a particular type of linear regression. When you have events that are rare, like hurricane counts, then there's a sort of version of linear regression called Poisson regression. And it's for, unlike a continuous quantity, like say temperature, you're looking at the number of discrete events. In this case, how many tropical storms we're likely to get. And there's a relatively small number, on average about 12 of them a year. So we use what's known as Poisson regression to find that statistical relationship in the past between the number of tropical cyclone counts, how warm it was in the tropical Atlantic, and what El Nino was doing. And so that leads in this case to an estimate of most likely around 20 named storms with an error margin of about plus or minus 4. So somewhere between 16 and 24 storms. So we can't rule out, for example, on the high end, a season that's nearly as active as the 2005 season.
Is this following a trend in any way? I was curious what your team saw when it's been evaluating hurricane seasons in recent years. Or are we seeing a trend?
We absolutely are, because while there's still some debate within the scientific community about how El Nino might be changing because of climate change, and that's a more subtle and nuanced question. there's no question that tropical Atlantic sea surface temperatures are warming up along with the rest of the planet. And so we know that that underlying structural change towards warmer and warmer ocean temperatures has a very clear climate change signal in it. And so that means that in the context of these sorts of predictions, climate change is clearly playing a role. It is favoring more active seasons, in my view. In my view, that's what the best data tell us. Now, there are some scientists who've argued the opposite, that other mitigating factors, for example, you might get more vertical wind shear in the Caribbean related to possible changes in El Nino. If the world were to become more El Nino-like, then you would see more vertical wind shear. And so that would be adverse to the formation of these storms. But thus far, nature appears to be moving in the direction of warmer conditions, more storms. Now, that's just the number of storms, and ultimately what we really care about when it comes to impacts, human impacts and impacts on our environment are these major landfalling hurricanes.
Right.
And that, there was an article that was published, in fact, just the other day in the journal, I think it was Nature Climate Change, demonstrating that as we expect, the most intense storms are becoming even stronger. So there is now a very clear trend when you analyze the satellite data very carefully, and we only have a few decades of satellite data, and there's a lot of science that goes into figuring out how you can take a satellite image and back out the intensity of the storm. So there's a lot of interesting science in how you actually do that. But Jim Cosson at the University of Wisconsin is really one of the leading scientists in that field, and has done a very careful analysis now that demonstrates what we all suspected to be true and what anecdotally feels like to be true, that the strongest hurricanes are indeed getting stronger. And that's really what we need to worry about. All other things being equal, of course, a more active season gives you more opportunities for those major landfalling storms.
No, I was definitely curious about that, and I wanted to switch gears here and talk about, because I know you were in earlier this year. You were in Australia during the bushfire season. I know you were spending part of your sabbatical there before this pandemic broke out, and it's just like a hurricane season. When it's in Australia, when it's hotter, it gives it more likely, and drier, it gives it more likely of an opportunity that there's going to be a massive bushfire outbreak like we saw. I'm curious, just as a climate scientist, being in Australia during that time, and what was that experience like?
Yeah, I would be lying if I, didn't say it was surreal, because I arrived in mid-December for a sabbatical that I had planned out 2 years ago. So it was a long-term plan to do my sabbatical leave in Sydney, working with scientists, primarily at the University of New South Wales in Sydney, on literally understanding the impact that climate change is having on extreme weather events in Australia. And so, of course, fate would have me arriving in time to literally witness in real time the most extreme weather events that Australia has been subject to, unprecedented heat and drought. And again, it's not rocket science, and you alluded to this. You make it hot, you make it dry, you're gonna get bigger, more intense, faster spreading, more pervasive bushfires. And we literally saw the continent of Australia engulfed in bushfires when I arrived, and that persisted well into the new year. And so as a result, I ended up getting much less research done, in fact, because I was spending most of my time actually talking about this real-time impact that climate change was having on Australia, and trying to help Australians sort of connect the dots and recognize that this tragedy, and it truly was a tragedy, was not a natural tragedy. It's a tragedy that has been, that is favored, if not caused, by human-caused planetary warming.
Right, and you're giving all this great information on Australian outlets, and you've been outspoken about this. At the same time, Murdoch outlets are showing disinformation.
Yeah.
I was curious when when you saw the reaction by some right-wing press, what the Morrison government,
Yeah.
was there anything that surprised you watching some people's reaction to that disaster?
Yeah, it sounds like you know your Australian politics here. I can tell. You know the players, the figures, and certainly Scott Morrison. You know, he's sort of their version of Donald Trump. He's a liberal. Now, don't let that confuse you. In the Southern Hemisphere, you know, because the Coriolis force reverses and liberals and conservatives switch places. So they call the conservatives actually the Liberal Party with a capital L. It really means neoliberal, which is conservative.
Was this the most bizarre example of climate denial you've seen in your career, or have you actually seen worse? Because I know you've battled with climate deniers quite a bit in your career.
Yeah, well, you know, what's interesting about Australia, it's a smaller country than the United States, about a factor of 10 smaller, 30 million roughly, rather than 300 million. You sort of feel that, sort of people know each other. There's sort of this friendlier atmosphere, almost a camaraderie. But another sort of implication of that is that it's much easier to sort of you know, to dominate the media landscape, and the Murdoch media has done that very effectively.
Sure.
But it also means that I had an unusual opportunity to reach fairly substantial numbers of people through my outreach and media efforts, and was on a number of national programs, like the Australian Broadcast Corporation has a show called Q&A, a weekly show, which means a panel of experts and an audience, and they're talking about, you know, sort of issues that are in the forefront. And in this case, this was the first episode of the season, and it was about the bushfires. And I was one of the panelists, and that gave me an opportunity to reach a large audience, and a number of other national shows and commentaries in the Australian papers. So I spend much of my time doing interviews, doing outreach, giving lectures, and reaching a lot of people. And so what was interesting was that I was literally coming face to face with some of the principal sort of climate change deniers in their politics. On the Q&A show that I did, there was a Senator, Jim Molan, who is basically a climate change denier. And there was a moment in the discussion, it sort of went viral. He you know, said that he keeps an open mind, you know, as if there's a real debate about the science, and he kept on repeating that. And then I used a famous maxim that Carl Sagan once used. You know, it's good to have an open mind, but not so open that your brain falls out. It was the perfect opportunity to do that with a live audience, and you know, and it got a lot of attention. It was probably the one moment that was. You know, that received the lion's share of attention. And so, you know, I had some interesting opportunities because I was able to go face to face with these folks. In fact, a week later, I was on the Australian 60 Minutes. They have their own version of 60 Minutes. And it was another panel discussion involving another fairly prominent you know, conservative politician, Barnaby Joyce. And went toe-to-toe with him on precisely this issue, and got a major concession out of him, actually. What was amazingly is, in that context, a panel discussion of experts, people from the fire suppression community, from the military, me, a scientist. I think he realized he wasn't going to get away with just sort of the standard denialist talking points, and he ultimately conceded that you know, there was a climate change connection here. He argued that the current government was acting appropriately, and that's where the disagreement was. And so there were a number of moments like that where I was able to really go toe to toe with some of the main protagonists and reach just a very large audience. And I experienced something that, you know, in the United States, I suppose as a scientist, I'm sort of a public figure. But in Australia, I was really a public figure during that period of time. I mean, people really knew who I was. It seemed like everybody had seen that ABC program. And so yes, while there was rampant, you know, the Murdoch media was pumping out this misinformation, they were actually on the defensive.
Right.
it was just obvious to the person on the street that what we were seeing, you could see it with your own eyes, you could smell the smoke, you could see it, you could see the fires in many places. And so it wasn't credible to deny that it was happening. And what you saw was the Murdoch media sort of backpedaling through the sort of stages of denial. It's, okay, well, maybe, maybe there is climate change, maybe there's an impact here, but hey, it's good for us overall. Or, the best thing to do is to just, change our fire suppression, adapt. We'll just adapt to this, as if Australians can possibly adapt to a crisis of this magnitude if it persists. And so, and because they were so publicly criticized, by a whistleblower from within their organization, by James Murdoch himself, they were completely on the defensive. And so they had to sort of retreat in terms of their attack machine. I fully expected to be vilified by the Murdoch media, and they didn't lay a glove on me because they were so much in the defensive. Now, what's unfortunate is that Australians in the end didn't really have a time to stop and take stock when it was over, because, as you know, they didn't get a break. No sooner were the bushfires over and the floods that followed, and then we were into the pandemic. And so that, in a sense, that denied Australians the opportunity to really reflect on what they had just been through. I'll be back there in next February to give the lecture tour that got postponed because of the pandemic. And it'll be an interesting time then to take stock of where things are.
And I'm curious, because it really was, with this moment of crisis, it really did put the climate crisis in greater focus. And I think about all the progress that was made through activism, through science communication in 2019. Then this crisis happens in 2020, and it really put climate, it gave climate a degree of attention that I have not seen before. And then this pandemic breaks out. Do you have any worry that that's going to shift our attention away from doing the things that are necessary right now on climate?
Yeah, I do. It was my worry was that we were having this remarkable moment, and it wasn't just Australia. Australia had sort of become the face of climate change to the world, and and we were all watching this with sort of this foreboding that, hey, this is us soon. Australia is sort of on the front lines, as I like to say. It's the worst, it's the worst continent you would design if you were worried about climate change, centered right on the dry subtropics, already very hot, already hot and dry, and sort of at the limit of human habitability. And so a little bit of warming, a little bit of drying sort of puts you over the limit. And so Australia, in a sense, is what happened there, what was happening there is a depiction of what we're all in for if we don't act on this crisis. And to some extent, we are seeing that here in the United States. The wildfires out west, the floods that we've seen in Michigan this past week, unprecedented hurricanes, superstorms making landfall. So I would say that we're all witnessing the impacts of climate change, but somehow in Australia, it had become so visceral. The images that were coming out. I mean, we all saw the horrifying and sad, images of kangaroos on fire, and it became, in a very sad and depressing way, iconic. This is the face of climate change. It's not subtle. It's not far off. It's not just polar bears up in the Arctic. It's us, where we live now, and it didn't quite have the opportunity, as you allude to really sink in. We didn't have that opportunity for the sort of reflection that it really deserved and required, because it was from, the frying pan to the fire, from one crisis to the next. This crisis, climate change, isn't going away. We'll get past coronavirus, although, not without a lot of unnecessary death and devastation. But we'll get past coronavirus. We'll get past that crisis. But this crisis isn't going away. And so the challenge, indeed, is for us to sort of pivot and to use the coronavirus instead as an opportunity to reflect on basic matters of, sustainability and sort of the precarious nature of our civilization and our dependence on resources, and how quickly that can all be turned upside down by a crisis, whether it's the acute sort of shorter term crisis of the pandemic, coronavirus, or the longer, more pervasive and persistent crisis that is climate change. So I think many of us in this sphere are really trying to use this as a teaching moment
Sure.
for us to reflect on conquering the even greater crisis that isn't going away.
Ty, I know I stole some of your questions. You want to jump in here?
Well, unfortunately, it doesn't seem like our politicians here in America, or enough politicians really around the world, are learning the correct lessons from some of these crises. And in fact, especially the Trump administration is actually taking this time to roll back environmental regulations to protect us from worse climate change. As a climate modeler, is there any way to quantify the impacts that some of these environmental regulations are having on potential greater climate change?
Yeah, thanks. It's a great question, and there's no question. There's the immediate impact that the policies that were put in place by previous administrations, and keep in mind the Trump administration is eliminating not only climate policies that were put in place by the Obama administration, but environmental protections that were actually put in place by past Republican presidents. A half century of environmental progress, and they're dismantling it in 4 years. If they get another 4 years, it will, it's difficult to even conceive how much damage that they will do. So it's critical that they not get that opportunity. They've done enough damage already. And so, under the previous administration, the Obama administration, there were a number of executive actions like the Clean Power Plan, new restrictions on methane emissions, higher fuel efficiency standards for automobiles through the EPA. There were all these things, and Obama had a divided Congress. Republicans had the Senate, so there really wasn't an opportunity to advance climate legislation through the Congress, which would have been ideally what we need is a climate bill. But that wasn't a possibility, and so the administration had to do what it could through executive actions. Now, it's a double-edged sword, because you sort of live by the executive action, you die by the executive action. Executive actions that can be implemented can immediately be de-implemented by the next administration, which is what's happening. So what Trump is doing is undoing a lot of the progress that was made under the last administration, progress which sort of gave us some credibility on the world stage. It was what allowed Obama to go toe-to-toe with China and get a bilateral agreement for substantial carbon emissions reductions that set the stage for the Paris Agreement, which was a monumental achievement. And all that came about because the Obama administration was able, again, to make enough progress through those executive actions that we could, in good faith, go to other countries and saying, we're doing what we can. We're being a good, we're leading on this issue. And of course, now we've completely backpedaled to not only aren't we leading on this issue, we're lagging the rest of the world. Donald Trump, if he was successful, would be the only president, national leader to pull out of the Paris Agreement. And he is literally trying to undo the progress, everything that Obama had done to help us make our Paris commitments. Now, the good news is that there's a limit to how much you can actually do now at the national level, because much of the progress has penetrated down or has come up from sort of the grassroots, from the local scale to the state scale to the regional scale. There's enough sort of bottom-up progress that's being made, and what companies are choosing to do. Companies that remain committed to our obligations under the Paris Treaty, the Paris Agreement, and states and municipalities. There's enough progress being made there that we will come close to meeting our Paris obligations. If we miss them, it won't be by a huge amount, despite the fact that we are getting no help. In fact, we're actually encountering resistance from the current administration. And so the good news is we're making a fair amount of progress even without leadership at the national level. Imagine what we can do if we have that leadership at the national level. And we're only months away from that possibility, from that opportunity. So to me, it's an exciting time because there really is an opportunity to move forward here.
Yeah, definitely. Now, I have some science questions for you. Let's get away from politics for a minute.
Science.
Right.
I geek out with the best of them. So.
Now, I've heard you say that humans are actually responsible for more than 100% of the warming that the Earth has experienced over the last 250 years. Could you explain what you mean by that?
Yeah, and when I say that, it's one of those things I say because it catches your attention, and it's true. It's seemingly impossible, and so then you invite the follow-up question. Well, how can that be true? And the reason that's true is that using climate models, we can sort of do counterfactual experiments. We can do experiments that are like what happened in the real world, where we increase the greenhouse gas concentrations from human activity, and we put the pollution that has an offsetting effect, sulfur pollution that actually has a cooling effect in industrial regions. We can put all those human factors in, and we can put the natural factors, like small but measurable changes in the output of the sun, the brightness of the sun, volcanic eruptions, which also put particles into the atmosphere that reflect sunlight, and so they cool the planet. And so what we can do with those models is we can put all the factors into the models, the human factor and the natural factors, and show that they reproduce the observations, they reproduce the observed warming. Then you can do a counterfactual experiment where you don't put in the human factor at all. And not only don't you reproduce the warming, if it was just the natural factors alone, the climate would have actually cooled slightly over the last half century. And it's because we've had a number of large volcanic eruptions, like Mount Pinatubo in 1991, and some smaller eruptions since then. And solar output has been flat or even slightly declining over that time period. So the natural factors alone should have cooled the planet, and we warmed in spite of them. That means that the human factor, the increasing greenhouse gas concentrations from fossil fuel burning in particular, not only caused us to warm, it offset what would have been a slight cooling. And so in that sense, we're literally responsible for more than 100% of the warming, because in the absence of those natural factors, the planet would have warmed even more than it has.
And you mentioned the sun cycles, and I know we're approaching a solar minimum phase, right? And that's expected to cool things a little bit. Can you explain what that means?
Yeah, so there are sunspots, and they go back to the time of Galileo, the telescope. So all the way back to 1610, we have these sunspot drawings of the sun with the sunspots, and you can actually go online and you can find drawings by Galileo himself of the sun with the sunspots, and they look eerily like a modern visible satellite image of the sun. It's very, he did a good job. And because of that, we have these records that go back in time. Now, here's one of the counterintuitive things. When you see black spots on the sun, you might think, well, isn't the sun cooler if it's not red hot and you have some dark spots? Those probably aren't as hot. When you turn on an old-fashioned stove coil, it starts out dark and then it becomes red as it heats up. So you might think, well, okay, if there's a lot of sunspot activity, then the sun is actually dimmer. And it's just the opposite, because what you can't see is that when there's more of those sunspots, there are also more of what are called facula, which are even brighter, sort of white hot areas. And you just don't see them, they blend into the background. And so it turns out that when you record more sunspots, the sun is typically brighter than it normally is. And you can sort of compare the sunspot data against modern direct measurements of solar radiance from satellites and sort of calibrate it. Okay, we have some idea. When the sunspots vary by this amount, we know from modern observations that the brightness of the sun varies by this amount. And so we can use that to literally reconstruct solar activity back in time. So over the roughly course of 11 years, there is a pretty strong cyclicity. It's the 11-year sunspot cycle. There tends to be sort of an 11-year periodicity in how many sunspots there are, and that means an 11-year periodicity in how bright the sun is. And that appears to be tied to sort of internal convection cycles. The sun is basically a plasma. It's a fourth state of matter. It's not quite a liquid, not quite a gas. It's something in between. It's like an electron gas. The electrons are stripped off the atoms. And it's this very hot plasma. And like any hot fluid, any fluid that's heated, say from below, you get convection, you get overturning, and it turns out that there's sort of an 11-year cyclicity in sort of these patterns of convection in the sun, and it's tied to a measurable 11-year cycle. The amplitude of that cycle translates to a fraction of a percent in the brightness of the sun. So it's sort of down in the noise, which is to say that if you had no sunspot activity at all, which is what happened during the period of the sort of early 1600s, a period called the Maunder minimum, when, after recording these sunspots, there was a period of about 30 years where there was essentially no sunspot activity at all. And we can sort of calibrate that and figure out how much lower the output of the sun, how much less bright the sun would have been. And it comes out to maybe 0.5%. And so if you do the calculation, that gives you, at most a few tenths of a degree, maybe 0.3, 0.4 degrees Celsius, less than a degree Fahrenheit change in the global temperature. And global warming has already given us, nearly 2 degrees Fahrenheit. So global warming now is a much larger factor than even the most dramatic solar change that we can envision, which is the analogy would be the Maunder minimum, when solar activity literally stopped for several decades. Even if we got another so-called grand solar minimum, a colleague of mine, Stefan Rahmstorf in Germany, published an article a few years ago where he showed that even if we got another grand solar minimum like the Maunder minimum over the next several decades, it would barely show up as a blip on top of the projected warming if we continue with business as usual fossil fuel burning.
Wow. Well done, humans. You warm the earth past even the most extreme solar minimums. That's wild.
Well, but it means it's empowering too, because it means that we have the ability to stop that too.
There you go.
Yes. Well, you and your colleagues, you published the hockey stick graph as a way to illustrate just how how extreme the global warming has been in the last few decades relative to the last 1,000 years. That was almost 30 years ago. How has this?
20. My elderliness has been vastly over. Rumors of my age are greatly. But yeah, it was on Earth Day, 1998.
Okay, all right. So that was a bit of an exaggeration 30 years ago. But how have you seen?
10 years older than I am. I'm already feeling old. My daughter tells me how old I am every day. So,
how have you seen the science field, especially this climate field, which is so interesting in science? How have you seen that become more politicized, and how has that made you feel as a scientist?
Well, it's frustrating, of course, because you go into science to deal with facts and objective, to model processes and to try to understand how the world works. That's what inspired me to be a scientist. And so there's sort of this innocence that you come with as a scientist, and the loss of that innocence is the recognition that the rest of the world doesn't necessarily see it that way, and that there are people who have a vested interest, not only in not listening to the science, but in actively attacking it and undermining public faith in the science. And So, I certainly, lost my scientific innocence early on. The irony about the hockey stick. So when we published the study, originally, we weren't that interested in the graph, the famous graph. We were our original submission to the journal Nature really emphasized our spatial patterns, where we were looking at the global patterns of temperature year by year, looking for old, past years where there were big El Nino events or volcanic eruptions, and seeing where it cooled and where it warmed. And so those were the sorts of questions, these motivated by an interest in climate dynamics that really, that motivated that work. And in the end, the scientifically least interesting thing you can do with those global patterns is to just average them over the whole planet to get a single number for each year. Scientifically, that's actually sort of boring, but it turns out that the resulting graph, which is the hockey stick graph, is what got all the attention.
Yeah.
And so in fact, we hadn't set out, and, with the intention or agenda of publishing a dramatic graph. It literally emerged from the science and from the feedback from the reviewers, who said, you should be really emphasizing this graph, and you should show how it compares to the modern warming, because the paleo data didn't come up to the present. And so we had to think about, how do you compare the past against the present using modern thermometer measurements. Little did I imagine back then that the hockey stick would become sort of iconic in the climate change debate, and that B, it would place me right in the center of the very fractious, political, ideological, societal debate over climate change and what to do about it. It's not what I signed up for. When I double majored in applied math and physics at UC Berkeley, I didn't think I was signing up for a career in politics. But ultimately, that's where the science led me, and ultimately, I've come to embrace that role. Because it's not what I set out to do. It's not what I envisioned doing. Probably, I would have been happiest just being left alone in the lab with the computer crunching data, what I love doing, solving problems. But I've ended up, I've been given an opportunity to, to have a role in this larger conversation about, what I often say is perhaps the greatest challenge we face as a civilization. And I feel privileged to be in that position.
Well, we certainly feel privileged to have had you on the show. I know we've kept you over time, so thank you for your time and your patience with us, and apologies for the technical difficulties.
No
But
worries.
Dr. Michael Mann, thank you again for joining the Climate Pod.
Thank you. It was a pleasure talking with you both.